Welcome to the lecture series on object-oriented analysis and design. In the previous lecture, we have seen why computer-aided software engineering tools are becoming more and more important. The scale and complexity of many systems we are currently attempting to build is severely stretching the capacity of existing software development methods and notations. It is not that we didn't do very good job. From 68, the time when we began to define a field software engineering, nearly 15 years later, we have matured certain very good principles, concepts, they are all well documented, well studied. 15 years is a very good time in a field of software development which was catching the attention of many brilliant minds. Little bit of an adjustment on what we did on the software engineering life cycle, processes, business requirements, technology, quality and people as practitioners approach happened for some time. Whenever we ran into a problem, we were looking for a technical solution because it is technology. Software engineering as a field was always indicating that it will be engineering, better engineering, technology, better technology. That is how we have been thinking about it. And as a result, we have been digging further in to see if I can come up with a better technical solution. One solution that has been remarkably unearthed or brought out from the cold storage is object oriented. It was there in 1950s, but the idea was so abstract, the terminology was completely different. People have written technical reports, people have published saying that this is how we interact with the real world, but then there was understandably a serious domination of tangible objects, things that we see and therefore we understand. For that, why do we need a big technology was a question. If I want to do this task, I will do that. I need 10 things, I will put the 10 things together and be done with it. It is a case of understanding that what we do, just like that, when things are so clearly visible, is not such a thing that is challenging for software. We need to push everything into an imaginary plane. At that level of abstraction, software begins to impact. This has been true right from day one. We do not look at the problem or a puzzle or whatever at a place where it has occurred. We want to abstract it out of the context, define it in a space where, let us say, it is about 3 or 4 levels above what is the ground level, and then solve the problem there, because that is where the power of software is. It gives you that genericity. Towards this, we have come up with very good software development methods, good notations, good practices and fantastic technology ideas. We are having about 7 or 8 paradigms, but still by 96, when we started taking a real stock of what is it that we are talking about is a successful project, the Standish group came up with chaos report, because at that point in time in 96, when the first report was published, our success rate was a dismal 16%. 84% of the projects are heavily overrun on the cost, heavily overrun on the time. What is the reason? The reason is this: software development methods and notations began to squeak. Not only this, we thrive on what is called dealing with complexity, as a matter of fact celebrating complexity. The more complexities, the better challenged we are, the sooner we will get into the abstraction and there we solve the problems. That has been the strength of the field and it is the core difference of this field. We are not likely to run into quick materials, components, get everything done as a tangible set of things and then do it. That we will do it. And we strongly think that if we do 10 things like that, we know what the person can do at the abstraction level. That is also true. We can also think, but somebody who is doing at the abstraction level, we will have to somehow manage to make them come down to see how they are doing these 10 to 15 things. So that is where the complexity lies. It is easy to scale up, but then what we need to understand is, from that abstraction we need to come down, and towards this extent we have realized that human beings also have limitations. What are the limitations? It is not only the design methods, it is human short term memory. Every given human being is able to link to around 7 to 9 things, or rather 5 to 9 things. depending on what they are doing. They can deal very quickly. If I tell that what is the impact of lifting this mouse, I can connect this mouse to about very quickly in my mind 5 to 9 things and understand it is not going to be a serious concern. Most of the technology ideas, most of the products that we talk about as engineering products do not tax us more than this. Talk about a television, talk about a car, talk about anything that we are calling as a technology or a well engineered product is not likely to stretch the human being any beyond this, whereas software does. Software expects, or rather the human mind itself will abstract and then start connecting to too many things. The short term memory of human being is limited. So, we are having serious limitations very soon in the profession, 70 to 95, hardly 25 years, and then we are hitting a wall on the notations, we are hitting a wall on the methods, we are hitting a wall on the people complexities, the ability to deal with complexity by the people, but the complexity will have to increase. And we are staring at a alarming success rate of only 16%, 16%. So, what do we do beyond this is the question. So, technology ideas, all that have been tried. Eventually what we did was we said let us bring about an idea called process. Out of the top 4 aspects that impact software engineering, namely business requirements, technology, quality and people, we have highlighted the idea of a process. By doing so, we made quality as the number 1. Everything that happens here is quality. Everything else is secondary to quality. If you talk, it's quality. If you do, it's quality. It's just exactly quality. What is this process that is reflecting everything else? We said let there be some standard process, otherwise we get doing things on our own. Each time we reinvent the wheel, we are going to face the same hazards. Had the success rate been not so dismal, 16%, we would not have probably come around to tell that yes, we will take the process approach or we will take the quality frameworks. There have been many quality frameworks, out of which by year 2000, CMMI and ISO 2000, ISO 9001, 2000, they got stabilized and we see some good metrics. Beyond 2000, beyond year 2000, we somehow got systems also into the loop, processes, systems and management. So many things we have been doing. So, what has happened in summary is the fact that outside of the software engineering core topics, we need to talk about organizational processes, we need to talk about supporting processes. Otherwise, we are not able to make head and tail of what exactly we started with. While everything began with a clear idea in the field of programming that there will exist one start, there will exist end. Somehow we will have to start at the start place and find our way to the end depending on the input, depending on the output. We will somehow reach the end with some output. End of the program is clear, start of the program is clear, but now the very idea of complexity that has stretched our methods, that has stretched our notations, that have severely challenged the human brain. I am not talking about people who are more than what the normal human beings are. I have seen people who can simply look at the DOS bytecodes and read it off. It is not so easy to read machine language zeros and ones, but then I have come across people who can read just like that the DOS code, MS-DOS, almost like give them a floppy. Those days we were using only floppy disks, MS-DOS boot diskette, they will simply look at the floppy and read what is happening. We are not talking about such accomplished people. Normally, by and large, we have a human memory limitation. So, we are not likely to connect. Therefore, in a field that was so individualistic, I have a problem, I have a puzzle, I have a unit, I have a function. Today, it is imperative to bring in teams. Everywhere we are talking about teams. Teams should talk same language, that is very difficult, because phases talk different language, every phase has its own notations and that is how they get defined, that is how we can delineate that this is this phase, this is this phase. Later on when we are tracing from start to end, it becomes very important that we have taken care of all these disciplines, we have also documented. So, 30 to 40 years of spanning across the field of software engineering, these are some of the lessons which we have learnt, and we know for sure that we will have to bring in teams. Not that every team member will be asked to remember more, but then if we bring 7 people, we are likely to sit down together and come up with 25 related things. Why are we so much interested in that? Because change is something which is a characteristic of software engineering. Without that promise of change, probably we would never have succeeded in the business in the first place. We have been telling all along that just do not bother, 70% of the requirements can be volatile. If 30% are stable, we will make it happen. It is a sort of a challenge which the software engineers face, and it is very unique to our profession. Just because there is a tag of engineering, we are not really comparing with other engineering disciplines, but this is how software is. This is how the technology called object oriented analysis and design has promised everything, but then we wanted to have the first step addressed very carefully. All this will fit into the groove if you have identified objects properly and definitely designed object identification and design. If that has happened properly, then all the benefits promised by this nice technology called object oriented technology are likely to happen, which we have been seeing from lecture 1. And what we need to understand is these are the challenges: complexity, how to go from requirements to design, detecting requirements defects early, accommodating change, how to get a set of requirements. These are the handful of challenges that is making us spend sleepless nights, get scared on the stiff deadlines. Most of the times we are worried about what will happen. On top of all this, what is absolutely essential to understand is, even after 10 years of experience in programming, 1 out of 7 lines is likely to be defective. If you are generous, 1 out of 10 lines is equally likely to be defective. So, if a 1 lakh lines of code has been developed, lines of code in any language is a very crude metric, it does not tell much, but 1 lakh lines of code has been developed, out of which clearly 10,000 are the defects. That means anything can go wrong. As I said earlier on, we are now not talking about bugs, we are not talking about issues very late in the cycle, we are talking about defect as a standard medium which tells that, well, it seems to be working, but it can very clearly, depending on some input condition, depending on some conditions, criteria, it may become a serious vulnerability, flaw, a huge risk. So, as of now it is defect. On an average, out of 1 lakh lines of code, 10,000 lines are defective. We hope that we will build some great compilers, we will build some fantastic ideas of intelligence, optimization going into the compiler construction. We will come up with great integrated development environments, programming development environments, good operating environments. After all this, 50% of that 10,000 is likely to be detected early. What happens to the remaining 5,000? That is the challenge we have as people who are doing software engineering, software development, whatever you want to talk, whichever technology it is. These are the most enticing challenges for those brilliant minds that have been tackling these challenges. So, we celebrate complexity, we want to go from requirements to design. Gradually, because of the systemic influence, how to get a set of requirements is the reverse. After finishing everything, you should know how to go back to the requirements, that is traceability from top to down and bottom to top, detecting requirement defects early, accommodating change. So, by now it is becoming very obvious that we keep on running into the same risks if we do not address these challenges properly. Is there a way? The human mind always says, if so many people are having similar problems, can we come up with a tool? Is there a tool? Thus, we began the quest of building computer aided software engineering tools. A tool is not going to do everything, it is not a panacea, it is not a wonder balloon, it is nothing, it is not a silver bullet. A tool will help us take care of these handful of things in a more cogent and a consolidated manner, and as we become more and more dependent on the teams, the organizational process, we keep saying that people come, people go, people leave the organization, then what do? At the end of the day, we talk about the most important lesson. If you have to change more than 10% of a code written by somebody else, you better throw away the entire code, redo it yourself. Don't change more than 10%. 10% is a big luxury. So we once again started looking at this OAD. We said, don't bother about so many things. In a good number of applications, we can package the existing code, use it properly, we can reuse. OAD has been promising a very, very wide range of applicability to address what we have been facing in the field of software development. Very promising technology, and we have taken a good look at what are all the applications that benefit from this technology. It is true that certain applications demand another paradigm. Other paradigms are also there, 7 or 8, but the focus of this particular series is object oriented analysis and design. So, having said this, these are the greatest challenges, and I am not willing to spend more time on this. If these handful of challenges are addressed properly, we will be happy, and since each time we are attempting, we are falling short of doing this well according to our own assessment, according to our own exercises, therefore we started building case tools. Tools are aiding and limiting our capabilities. Tools also change. Tool dependency is dangerous. We cannot depend on the tool because tool cannot ensure safety. It's people who ensure safety. Tools change, tools aid and limit our capabilities. All these are well known, but then is the best bet. People have work, they can work from various places, wherever they are, they can pool in their ideas, they can co-develop, collaborate, the ideas are good, and we build case tools specific to what is called the object oriented technology. Are there some tools like that which are specific to object oriented analysis and design? One tool that has withstood the test of time very, very admirably is what is called Rational Rose. So, this set of slides is called Rational Rose. Rational is an organization, Rose is what they developed as the tool. The tool's name is Rose, developed by Rational Rose. In theory, we have always been talking that the unified modeling language with all its diagrams, all its fantastic facilities to help us do all these 5 challenges has been done exceedingly well by Object Management Group. Object Management Group brought together many leading industries, many pioneering computer scientists to pool their thoughts together and tell that why this wonderful idea called object oriented analysis and design is not able to scale the way we expected. Not only that, it is getting fragmented, people are not even able to identify objects. So, year 2000 is also known for unified modeling language happening very soon. 2001, 2002 we got very stable basis of unified modeling language. Unified modeling language which stood the test of time of 20 years. Rational Rose was one of the very, very pioneering efforts in creating a case tool that is in tandem with unified modeling language. 18 years, most textbooks, most books, most works have been talking only about unified modeling language. Any other method has been fading away into oblivion. The most dominant method, unified modeling language. If so many industries, so many eminent scientists and brilliant brains are working, we are not classifying it as academic, business or whatever it is a fact that it works and it has been working within its limitations. It has its own limitations, people are stretched, people are still cursing this UML, but this is something which is very generic. It promises the unification. We are now no more talking about software development processes, organizational processes, supporting processes, everything is unified. Everything is a good model. Within that ambit of the model, it is becoming predictable, it is becoming anticipatable. All models are wrong, but these models are useful. More importantly, it is a language which is different. It is not natural language, it is not a computer language, but it's a language that talks about everything that you are doing in a spell of 11 things and 9 diagrams. 9 diagrams, 11 things. The combinatrix of just this many ideas is giving you a fantastic range to address virtually every application domain to a larger extent. If they are suited particularly for OOAD, we will progress further. Reusability, existing code can be bundled as a package and used. All these we have been illustrating. The pluses of object oriented analysis have a very high potential to succeed if we are going through this method of unified modeling language. There is an object constraint language, there is an object factory, object tree, there are so many other things. So, a tool, a computer aided software engineering tool which came into very huge popular use is Rational Rose. However, I am not indicating that this is the best tool or the only tool. As we keep progressing, we would understand that the success rates are like this. You please look at what is the success rate here. The successful teams, all teams are around 52%. If they go through all these processes, it is nice. Traditional and ad hoc methods are taking you up to 30%. This is what was the result. Once we started using tools like object oriented analysis and design based methods or Rational Rose, iterative process, everything becomes seamlessly integratable. Originally it was just around 30%. Soon after we started using these tools, changed the method a bit, iterative 36% success. So, we normally quote this success rate. By and large, we are now confident that we are here. We can hover around 36% by using some iterative development. Agile shot into fame because it is 55% success rate. Even recently we have been talking about it. Why the other percentage looks bleak? It is a serious case which we have to talk about it later. Continuous delivery, lean, 70% success rate. All teams, all varieties of things happening, we are about 50% successful. So, what is the concern here? The concern here is that just by looking at the green band, we cannot say anything because iterative, the failure rate is phenomenal. The red is huge. That is the concern here. So, therefore, we hover around only this. Normally, we are responsible software engineers. We tell saying that everything is fine, spick and span. We feel challenged. It is a very good idea, very good thing to start with. However, please note that on the business requirements of delivery on time within the estimated budget, our success rates when we are measuring are about 30 to 36%. If that is fine, we will sign the contract and proceed. We will have to use more other things like, as I mentioned, user driven development, test driven development, component based development. We will come up with better ideas. So, here it is continuous delivery and lean, not many applications. The green band is very attractive, very attractive green band, 70%, close to 70%, but then we do not have that many applications. A lean team is hardly about 5 to 7 people. What can 5 to 7 people do when we are talking about millions of lines of code bases that have to be put together? However, it has its own pluses. So, we should understand that even though we are able to show some progress and success beyond 36, it is severe riders and constraints, and therefore, we are very right in telling that most of the times we are challenged. 70% of the time we are not so confident, and with a great push, with more time given, more money spent, we are likely to get into the yellow band, and that is sapping in a different way. We are not likely to do much because it simply means that we start developing on the customer side most of the times, or in the name of maintenance we redo the exercise. So, this is how we have been talking about. This band of 70% roughly is not so easy to manage. We are stiffly challenged, agreed, but that is how we have been. Roughly 30 to 36% we are talking about as something which we can do. It is doable. We have had good systems, 10 years of track record, good way of managing the exercise, adhering to standards, adhering to various other aspects of quantitative analysis, quality frameworks, good systems thinking. All this is required to get to 36%. Please note, that is the challenge, that is the charm in our field. Primary strategy for modeling. What do we do in modeling? Ad hoc, there was no modeling at all. There was absolutely no modeling. Traditional, we talk about, again, most of the times we think that it is enough if we sketch a little. The blue band is sketch to think and communicate. Draw some block diagrams, make some simple ideas happen, put some sketch pen ink and then go ahead, sketch and capture key diagrams. Gradually the blue band began to emerge, but then it has not done much outside of UML iterative in the traditional manner. The blue band has just begun to happen. This is serious for documentation. Lot of modeling techniques happen. This model is good for making a document clean. This is how we talk about standards. I did mention about style guides, Chicago style guide, American Psychological Association, their standard guides, SBMT to generate code, SBMT for full trip engineering. So, what we need to understand very carefully is that we have to have a way of building a modeling technique outside of sketching, building and modeling tools. We have had good tools and techniques for documentation, for generating code and for full trip engineering, but they have not come into focus. In summary, until UML came, until a case tool for UML came, we were not at all confident of this idea called modeling. Case tools have greatly enhanced our capability to address both complexity and modeling simultaneously. That is the reason why people began to invest. 20 years now, UML withstood, and along with it the idea of case tool required to address exactly a handful of challenges in software engineering, and this much is happening with a promised success rate of 30 to 36%. Thank you. We will meet in the next lecture.